Good. So now we're ready to get the covariance. So the covariance of x with y is just the expected value of x times y minus expected value of x times the expected value of y. Right? This is sort of like that inside-outside formula for variance. Okay? But it's not. In this case, this will be, so it's going to be 6.4 minus 1.8 times 3.5, right? And that comes out to be 0.1. Heck yeah. Now, we're going to have to go and get the standard deviations for x and y in order to get the correlation coefficient, right? So, standard deviation for x, that's the square root of the variance of x, right? So that is, let's see, now I'm going to use that inside-outside formula. Inside minus, right, like that. Okay, so what is the expected value of x squared? Well, glad you asked. What could x squared be? Well, it could be 1 squared or 2 squared or 3 squared. Right? These are the values of x. Okay. It's going to be 1 squared with the chance that x is 1.3. Right? It's going to be 1 squared times 0.3 plus 2 squared times, what's the chance that it's 2? 0.6 plus 3 squared times 0.1. See that? Because x is 3 with probability 0.1. Again, I'm using the marginal distribution for x down here to get this stuff. Okay. Of course, I have to remember to subtract off the mean for x and square it. The mean for x was 1.8. Squared, like that. Okay. This turns out to be, I think it's root 0.36. Guess I better check that. 1 squared is 1 times 0.3 plus 4 times 0.6 plus 9 times 0.1 minus 1.8 squared. Yeah, 0.36. And the square root of that is, of course, 0.6. Okay? That's the standard deviation of x. Now let's get the standard deviation of y. Works the same kind of way, right? It's the square root of the variance of y. So this will be the expected value of y squared minus expected value of y quantity squared. So this will be the square root of, let's see, y is 2 with probability 0.4, right? So that's 2 squared times 0.4. Or y is 4 with probability 0.3, so it's 4 squared times probability 0.3. Or y is 5 with probability 0.3. Then I got to remember to subtract off the square of y. Sorry, the square of the expected value y. It's 3.5. All right. So this is, let's see, what does that turn out to be? 4 times 0.4 plus 16 times 0.3 plus 0.3 times 25 minus 3.5 squared is 1.65. 1.65. Okay, and the square root of that is about 1.28453 2 5 8 7 9 1 2 3 4 5 6 7 8 9 something. Okay. Whew. So finally, the correlation of x and y, sometimes called the correlation coefficient, sometimes called the linear correlation coefficient, sometimes just called rho, and sometimes just called none ya dang business. It's the covariance x with y over the standard deviation of x times the standard deviation of y. It's going to be 0.1 in this case divided by 0.6 times 1.284523258, whatever, okay? And that turns out to be about 0.12975, okay? So I would say in this case that x and y are not very associated. Not very associated. Because this number is, it's relatively close to 0. The closer it is to 1, the more positively associated they are. Like 0.8, 0.9, 0.95, certainly, maybe even 0.78. The closer it is to -1, the more negatively associated they would be, like -0.8, -0.88, -0.95, something like that. Anything like 0.1 or 0.2 or -0.1 or -0.2, it's pretty weak association, if anything at all. And what's the rule? What's a strong positive association? There is no rule. It's only just a bunch of gray area. It's just a bunch of gray area. Great area. Great. Areas are great. Okay? The rule is the closer it is to 1, the more positively associated it is. The closer it is to -1, the more negatively associated it is. You always hear people say that less is more. Well, that's not really true. It turns out more is more. Okay? And that's all there is to this story.